Hello everyone, hope you are doing good. So today we start our journey by discovering the powerful world of Unix and Linux systems. Actually, whether you have a background about the open source operating system or not, really understanding the fundamentals is like gaining access to the key that unlocks the true potential of these systems. So let's start with Unix and Linux, which have been the backbone of countless servers, devices, and even personal computers. They provide stability, flexibility, and really robust environment for beginners and also for professionals. So in this course, we'll explore the core principles that shape the Unix-Linux philosophy, the unique file system hierarchy that structures the operating system, and the elegant simplicity of the command line interface. So, without further ado, let's uncover the types of Unix and its common terms as well as the components of its distribution. Then we will explain the Linux boot process and finish this lecture by the FHS, which is the File System Hierarchy Standard. So, what is Unix? Unix is an operating system that was first developed in the 90s and has been under constant development ever since. It's actually a stable multi-user, multitasking system for servers, desktops, and laptops. There are many different versions of Unix. The most popular varieties of Unix are Sun, Solaris, Linux, which is GNU, and Mac, which is Macintosh. So let's start with Linux. So Linux is a family of open source, Unix-like operating systems based on the Linux kernel. An operating system kernel was first released on September 1991, I think. Yeah, 1991. And Linux is typically packaged in a Linux distribution. And these distributions include the Linux kernel and supporting system software and libraries. The popular Linux distributions include the Debian, the Fedora, and Ubuntu. For Solaris, which is a proprietary Unix operating system originally developed by Sun Microsystems, and we have the Macintosh, which is previously Mac OS X and later just OS, means operating system X, which is a series of proprietary graphical operating system developed and marketed by Apple. Actually, we have many other types of Unix, but we'll be focusing on Linux. So we mentioned that Linux we mentioned that Linux has different distributions that includes the Linux kernel and supporting the system software and library. So the kernel here is a crucial component of an operating system, acting as the core that interacts directly with the computer, which is here the computer hardware. It serves as an intermediary between the hardware and the software applications, managing system resources and providing essential services. So the key aspect of the kernel are three principal parts. The first one is the hardware interaction. So the kernel will communicate with the computer's hardware, including the CPU, the memory, the disk drivers, the input-output devices, and more other. It also translates the high-level commands from the software application into a low-level commands from software application. So it translates the high-level commands from software applications into low-level instructions that the hardware can execute. The second aspect, or the second key aspect of the kernel, is the resource management. As the kernel manages system resources, allocating and deallocating memory. It will also be responsible of scheduling tasks, processes, and controlling the input-output operations. More than that, it ensures the fair and efficient use of resources among different processes running on the system. Now, the next key aspect of the kernel is the device driver. So the device drivers are specialized programs within the kernel that enable the communication between the operating system and a specific hardware device. For example, if we have printers for when we are using the graphical cards, etc. So the kernel here will use these drivers for example, printer to abstract hardware complexities and provide a standardized interface for software application. So as you can see here, really kernel is very powerful and is really good and helpful. Okay, now let's jump to the next part, which is the distribution. So we mentioned that we have multiple distributions or its base distribution. So a Linux distribution, often referred to as a distro, is a complete operating system built on the top of the Linux kernel, which you can see it here. So it includes the Linux kernel, system utilities, libraries, and often additional software application and a package management system. So the purpose of this distribution is to provide users with a complete and cohesive environment for running their application and also managing their systems. So the key components of Unix of a Linux distribution includes 4 parts. The first part is the system library. So which are the shared library that provide essential functions to system programs and applications. The second key component is the graphical user interface, the GUIs. So the desktop environment and window managers that provide a graphical interface for users to interact with the system. GUIs here will include features like desktop icons, taskbars, and application launchers to make things easier. Another key component for distribution is the email utilities. So, which about the software for sending, receiving, and managing email. And this may also include email clients, servers, and others. The fourth aspect is the fourth key component is the web browser. So applications that allow users to browse the internet, the web browser here will handle rendering web pages and executing the JavaScript. So the collection forms of the operating system distribution, and one of the most important is the Debian, which is one of the oldest family. The next one is the Ubuntu, and we have the Mint, which is new to Linux. We have also Kali, which has the information security, and Raspbian, which is the embedded system. So let's start with the Debian. We said that Debian is one of the oldest and well-established Linux distribution known. So this distribution known for its commitment for stability. Debian forms the base for many other distributions, including Ubuntu. Now, Ubuntu, as we said, built on Debian, so it's user-friendly distribution with a focus on ease of use and accessibility. It's widely used for desktop and server environments. Now, Mint, which we mentioned that it's new to Linux. So this distribution designed to be user-friendly as Ubuntu, but here Linux Mint is often recommended for users new to Linux. It provides a familiar desktop environment and it tries to include, or actually it includes multimedia codecs out of the box to make it more friendly and more easy for the beginners users of Linux. The next one said is Kali, which is specialized distribution focused on information security and penetration testing. Kali Linux comes with a wide range of security tools, free and stat. So from here you can see the difference between these distributions. So each one has a specific thing. The last one, which is the Raspbian, which is embedded system. So it's for embedded systems, specifically the Raspberry Pi Raspbian, which is optimized for Raspberry Pi hardware and includes tools for developing embedded applications. So to summarize, each of these distributions caters to different needs and preferences. So you can see the difference between the Ubuntu, the Mint, the Kali, the Raspbian. If, for example, you have some information about security, it's better to use Kali, etc. So users choose a distribution based on factors like their level of expertise, which, for example, if you are a beginner, you can just use Mint, which is easy for beginners. For example, if you are expert and you want to work with embedded system, it's better to work with Raspbian. And here it will be desired balance between stability and cutting edge software. So as we mentioned, or as we said, they are all good, but when we use one rather than another, it depends on our need. Okay, so next one is the bootloader or booty. So let's start with the bootloader, which is a program responsible for initiating the boot process and loading the operating system into the memory. Again, the bootloader, as its name mentioned, is responsible for initiating the boot process and loading the operating system into the memory. Now, the booting is also the overall process that takes the computer from being powered off to reaching the login screen. It's really short period, but this is called booting. So the first, as we said, it's program that boosts the operating system. The process that takes the computer from power on to login screen is booting. So let's start with the first part, which is the BIOS, the abbreviation of Basic Input Output System executes MBR. So BIOS is loaded from non-volatile memory on the motherboard into RAM. BIOS initially does an integrity check of HDD, SSD, RAM, and user peripherals like keyboard and monitor. Once this integrity test is successful, BIOS loads the MBR, which is the master boot record, stored on the first 512 bytes of the disk storage system. So here the first step is by the BIOS. Now, after the BIOS loading the MBR, so the master boot record. What will be the role of the master boot record? So the MBR which identifies how and where the computer's operating system is located on the disk storage system in order to be loaded into the computer's main memory or random access memory, the RAM. Essentially, the master boot record is responsible for getting the grub, which is the Grand Unified Bootloader file loaded into the RAM and executing it. Now, what is the grub? So as you mentioned, is Grand Unified Bootloader. So once the BIOS sees that grub is running in RAM, which was done by the master boot record. So once the BIOS check and see that the grub is running in the RAM, it passes control of the file system to it. Now the grub is taking the responsibility. The Grand Unified bootloader is responsible for two major tasks. The first one is that to locate, extract, and load the kernel image file, which done with the VM Linux. And the second task is to extract the init RAM fs file. This is the major two tasks of the grub. Now, the kernel. So the kernel's job is to load hardware drivers and start the first process called systemd. Now, what is systemd? Systemd is the one responsible for reading the configuration file that brings the system up to the defined run level of services the computer will start with. Okay, here we have another new term, the run level. So the run level programs are executed that start and stop services. Run level are the different operation states defined by specific sets of servers. We have many type of run levels, but we'll be focusing on these 4 run levels. The first one, the run level 1, which is a single user mode, or sometimes called maintenance mode, and it is often used for system maintenance or troubleshooting tasks, which is similar to the Windows recovery mode. The run level 2, which is a multi-user mode, but it's without networking, and run level 3, which is multi-user mode, but the difference between run level 2 and run level 3 is that the run level 3 is with networking. However, the run level 2 is without networking. The run level 3 is working in normal mode. And the last run level is number 6, run level 6, which is the reboot. Okay, so for Linux, we have, or in the background, we have some services or daemons that they are executed. Services are processes that usually run in the background and respond to requests from other processes running on the same system, or sometimes processes connected via network. So it's not really necessary to be on the same network. Many services usually run as daemons. Sorry. A service can call another service without any human input. After a service calls another service, those services can interact with each other automatically. And here means by automatically without any human intervention. So it will define how a server behaves. So to ask or to know how a service behaves, the answer is we cannot know because, or the only way to know is to check the configuration file, because this is where you will find how the service behaves. Now, the second term, which is the daemon. So the term daemons are processes that are constantly or continuously running in the background, rather than being interactively controlled by a user through the character user interface or the graphical user interface. Means you can control this daemon or service by some button, for example, or something in the graphical or character when you are using commands. So daemon processes are usually launched when the operating system starts, and it will continue to run until the operating system shuts down. The service or the daemon are often used to refer to programs that run in the background to respond to various events or requests or system conditions. We have some types or examples of daemons. The first one is the HTTPD. D means daemon. So this daemon or service is responsible for serving the web page over the HTTP protocol. Means it will handle the incoming HTTP requests, process them, and send the appropriate responses. Now, the second daemon, which is the FTP daemon. So the FTP daemon provides FTP, which is the file transfer protocol. So if you recognize that we are using the name of protocol HTTP, FTP, DHCP, which are protocols with daemons. So this is the daemon or the service that will work with this protocol. So the FTP daemon will allow users to transfer files between their local machines and the server over a network. Now, the DHCP means the DHCP daemon, which is responsible for dynamically assigning the IP addresses and other network configuration information to devices on network. So this daemon will respond to the DHCP request from client devices. So as you can see here, every daemon has its own role or mission to do, or things to do, or requests to answer. Okay, now the file system, the hierarchy standard FHS. So first, it creates a predictable file structure for users. Means the FHS is standard that defines the organization and layout of files and directories in a Linux distribution. This file system will aim to provide a consistent and predictable file structure across different systems. The next one is that Linux directory structure is like a tree, which is something you can see it in the picture. So here, as you can see, that directories are organized in a way that reflects the relationships between files and their function. Now, the base of the file system hierarchy begins at the root, which is symbolized by forward slash. So here the root directory is the starting point for all other directories in the system. Now, the directory separator in Linux is symbolized by forward slash, like the root, but here it's used to separate directory names and file names in the path. Let's see an example of a path. So here we have forward slash user forward slash local forward slash bin forward slash apt. Let's break down this path. The first part is the forward slash, which defines the root, or it means the root directory. The second part, the user, which is the top level directory containing user related data and programs. Now, the local which is the subdirectory within the /user for locally installed files. Now the bin means also a subdirectory within the user/user/local where executable binaries and images are stored. And the last part of this path is the apt, which is the specific executable binary file. So here we are mentioning the executable binary file stored in the bin, stored in the local, stored in the user. Okay, now the magic command line interface. So it is text-based interface in which users interact with computer by just typing some commands in the terminal or the console. It is non-graphical text interface to the operating system, which is unlike the graphical user interfaces, the GUIs, which use the visual elements like windows and buttons. The command line interface here will operate purely through text, only text. You will not find images or buttons or whatever. The user will input commands and it will receive text-based outputs. So the user types in commands for the operating system to execute. So user here, as we said, he will communicate with the operating system by manually typing commands, and each command corresponds to a specific operation or task. This command line interface is direct, efficient, and precise. So the command line interface is often praised for its directness, efficiency, and precision. Because you have, for example, one word that this word has a significant meaning and it will do some specific thing. So experienced users here can perform tasks quickly by entering concise commands without navigating through graphical menus. Sometimes to, let's say, rename a file, you will need to go in Windows. I'm talking about Windows now. You need to go to this folder and check if you have a large number of files in this folder. So you need to search the appropriate name or the looking for a file in this folder, then rename this file. In the command line interface, you will see it's just two or it's less than one sentence. So 3 or 4 words and it's done. So you don't need to go over the first folder, second folder if it's the case, then search for the file if it is there, etc. One other good thing about the command line interface is the automation of tasks. So the command line interface allows users to automate repetitive tasks by creating scripts. These scripts are like sequences of commands that can be executed together, enhancing efficiency and consistency. And using these scripts, you will be gaining much time. So you can say, for example, a script that look for a file, open the file, read the file, and save it in another file, and then close the file. So if you are doing these steps multiple times, you can save these steps in one script and reuse it whenever you want. So this is for the command line interface. So let's see what is the difference between the command line interface, between the shell and the bash. So we see the characteristics of the command line interface. Now the shell. The shell is a program that provides the user interface for interacting with the operating system. It interprets users' commands and executes them. So what is the role of the shell in the command line interface? The role is that the shell is responsible for taking the user input, interpret these commands or the commands of the user, and facilitate the communication between the user and the operating system. For the shell, we have multiple types of shell. We have the bash, which is the bound again shell. We have the Z shell, and we have the fish. And of course, each has its features and capabilities. Bash is one of the most widely used shells in Unix-like operating systems, including Linux. We will see Bash in the upcoming lectures. Now, let's go over the Linux system. So we can see that we have several parts in the Linux system. The first part is the hardware, which has the CPU, the RAM, the HDD, or sometimes called storage. Let's start with the first one, which is the CPU, which is the abbreviation of the Central Processing Unit. The CPU is the core processing unit of the computer. It executes instructions stored in programs, performing calculations, and managing data. Now, the RAM, which is the abbreviation of Random Access Memory. RAM is volatile memory used for temporarily storing data that the CPU is actively working on. It allows quick access to data and programs. So it will make life easier for the CPU. So instead of every time go to the memory of the computer, so the CPU will know that the program or the programs will be stored in the RAM, and this will allow quick access to the data and programs. Now the HDD, which is the abbreviation of the hard disk drive, or sometimes called storage. So the HDD or other storage devices provide long-term storage for the operating system, applications, and user data. Unlike the RAM, which is the random access memory, which is short, the HDD is long-term storage for the operating system applications and user data. Now, the second part is the kernel, which is the core of the operating system that directly interfaces with the hardware. The kernel actually manages system resources. It will schedule processes. It will handle the memory management, and also provides session services to the upper layers of the operating system. The kernel is really powerful as it's responsible for communication between the software and the hardware, and here its role is to ensure a smooth operation for the entire system to make this communication fast, efficient, and smooth. Now, the shell, which as we said, takes the commands from the user and executes the kernel services. So it will interact with the kernel and the system. And the shell can be customized, and different shell, as we said, bash, Z shell, or fish, offer various features and functionality. Now, the last part, which is the utilities or application program. Utilities and application programs are the software application that run on the computer, and also it enhances its functionality and allow user to perform specific tasks. So what is the difference between the utilities and the application? The utilities are the system tools and programs that assist in managing and maintaining the system, such as, for example, file management tools, the text editors, the system monitoring utilities, etc. However, the application programs they are the user-level software application designed for specific purposes, such as, for example, web browsers, office suites, multimedia players, etc. So, to summarize, the Linux system operates with a layered structure, with the hardware forming the foundation, the kernel providing essential services, the shell acting as an interface for user interaction, and the utilities, application programs that are responsible for adding functionality to the system. This layer that you can see it in the picture architecture contributes to the flexibility, efficiency, and the power of Linux-based operating system. This is the history of the Linux and Unix. See you next in the next video. Thank you.